Hey everyone, in this activity we're going to be looking at manipulating strings with the stringr package. Specifically, we're going to look at how we can match or find particular instances of a string, and also how we can modify, alter. Some examples of that would be concatenating strings together in R. So we'll open up our Markdown like usual and start by loading packages for the activity. Okay. All right. The stringr is a part of the tidyverse, but loading it here separately just to be explicit about the fact that we're using it extensively in this package. So we'll be learning about strings in this activity. Kind of in a way learning about string theory, if you are familiar with that in physics, but not that string theory. We'll be learning about character strings in R. Okay. So I would say this is one of the, I don't want to say weaker aspects of R. It's not really what people think of when they think of the strengths of R programming. They don't think of character strings or natural language processing as being a strength of R. So I'd say this is not the flagship of R. It's not what R touts as its main contributions to data analysis and statistics. But that being said, strings are still a very commonly an essential aspect of data cleaning and analysis. So it's important to be able to know how to use different methods in R for analyzing or cleaning up character strings. Okay. Hadley Wickham, just like in many other areas, has extensively improved the usability of R for working with character strings, specifically through his stringr package that he made, which is a part of the tidyverse. So here's the hex logo for the stringr package. So we'll explore the stringr package by looking at data on Taylor Swift songs. So specifically, we will look at the lyrics for each song that we have, the full lyrics for every song. So each observation in this data set is going to be a song. We have the name of the song, and then information about corresponding YouTube videos for each song here. So the title of the YouTube video, and then the YouTube API, the YouTube application programming interface where this data was obtained from, gives the duration of the YouTube video in a character string. It's not a nice date time format. So we'll look at how we can handle that, which is a common issue that when you get data, it can be the case that you want it to be not a character string, but you'd rather it be numeric or a date time type, but often you get data in a character format. So we'll look at how we can work with that and still clean it up to get the information that we want out of it. So we'll copy this code exactly to start to import the data on Taylor Swift songs into R. Okay. So there's many more variables than the ones we're looking at today, but I created this character vector of the variable names that we can use with the select function to subset to just those 4 variables here. Okay, and then we can look at the glimpse output and skim output just to get a quick idea of the data that we're working with before we are off on our way. Okay. Make sure you loaded the packages up here before we can use the skim function and the glimpse function. We'll need to have loaded these packages first. Okay. So let's take a look at this and knit this document. Okay. All right. So kept it a little bit more manageable here with the songs only having 4 variables for each of the songs. And so we have like the song title, the YouTube title, which is similar to the song title, but not necessarily the same. Here is the unique YouTube video duration. So how long each YouTube video is time-wise. That's given in this strange format, to be honest. The first video, for example, for the song Ready For It, is 3 minutes long and 31 seconds. I think PT might stand for like partitioned time, something like that. But essentially every YouTube duration value starts with PT, and then it gives these later values. So 3 minutes, 56 seconds for this video, 4 minutes, 24 seconds. Okay, so it's kind of, the information is there, but it's enclosed or encapsulated in this character string. And then we have the full song lyrics for every song. Okay. No missing values. Let's see. Yeah. 151 songs total. This is all of Taylor's main songs she's ever published. Okay. So next, let's look at how we can match character strings. So we'll be focusing in on the full lyrics variable, which has the lyrics for each song that Taylor Swift has written. So we'll look at first here, for example, her song, It's Nice to Have a Friend. Okay, so using this code here, we can display the lyrics for that song. Should be able to see the same output pretty much. Okay. So it's a one really big, really long string. Okay. You may notice these backslashes in here. So character strings are enclosed with double quotes or single quotes. So it's problematic when like the data from the API, for example, here came with double quotes inside it, because then R wants it to be enclosed in double quotes, but that gets messed up with where it ends or begins the string. So R handles that by using this backslash as like an escape. So it says essentially, this is a special double quote that we don't want to break up the character string because it has a backslash immediately before it. That detail doesn't matter too much, but just mentioning it here to show why these are occurring, even though if you look at like the original lyrics for Taylor's songs, these backslashes are not here, just the quotes. Okay. All right. So matching strings. For example, we may be interested in determining if she mentions a particular word in any song. Okay, so for example, here she mentions the word babe, questions, school. We want a programmatic way in which we can detect if a song mentions a particular word or not. And the string detect function allows us to do that. So for example, here, we can detect, print it in the console here so it's more clear. We can detect in this character vector that has Taylor Swift, Taylor Lautner, and Harry Styles, if we can return a Boolean value, a true false value, for whether or not each string in the character vector has the substring Taylor. So we see that's true for Taylor Swift, true for Taylor Lautner, but there's no Taylor in the name Harry Styles. So that returns false. So this is a programmatic way in which we can detect the presence of a particular substring. We can use this string detect function in tandem with the mutate function to create a new logical or Boolean variable in the Swift songs dataset called contains midnight to indicate whether or not a song mentions midnight at all. So like this was of interest recently because Taylor released a new album called Midnights. And I know some major Swiftie fans, some major fans of Taylor Swift were curious about which song she previously mentioned the word midnight in before. Okay. And so, yeah, a lot of like very dedicated Taylor Swift fans parsed through all 100, the over 100 songs of Taylor Swift, looking through to find the word midnight. Okay, they parse through all of the lyrics themselves by reading them, but we can do this in a programmatic way so that R will do it for us. Okay, so let's do that. All right. So we're going to add this as a new variable to Swift songs. So we make sure we reassign it here. We're using a call to the mutate function. And so we're going to say the new variable we're creating contains midnights equals string detect pattern equals midnight. Okay. And then we want the lyrics variable here as being the first argument to string detect. So it's full lyrics. So we can run this. And here we see a Boolean vector. Okay. We can see many songs don't have the word midnight, but there are some that do. So for example, 22, she mentions the song Midnight, evidently. Some other ones hanging out in here. Oh, okay. New Year's Day, a song from her Reputation album. So this one, she mentions midnight. Okay. So a few times. So let's see, how many of Taylor's songs mention the word midnight? Okay. So let's think about how we can do this. So contains midnight is true if Taylor mentioned the word midnight in the song. So we can calculate that. How many songs in total? In a few different ways. One way we could do that is to pull that variable out and then take advantage of the fact that R views true as being numerically equal to 1. For example, true plus 2 is 3, and false as being numerically equal to 0. So we can sum the contains midnight variable to get the number of songs, the total number of songs that mention the word midnight. So 6 songs out of her 151 songs mention the word midnight. Some caveats here, though. So when we match character strings like this with the string detect function, note that character strings are always case sensitive, unless we went through extra work to use special arguments to the function. Otherwise, it's only matching the word midnight if it's all lowercase. Okay, so capitalization matters here. This often is something we have to consider when working with character strings, because capitalization, if you're lucky, it's going to be consistent throughout your data set, but chances are that it's not. Chances are sometimes midnight is capitalized, sometimes it's not. And that's just how it is with data. So we have to adapt and be flexible for that. One way in which we can work around that is to not just match lowercase midnight, but here we could match midnight with a capital M as well. And so to see how we can do that, here we can see we just match Taylor, okay, with a capital T. It doesn't match all of the Taylors. It only matches when the capital T is in the word. It doesn't match like the second one. Okay. But we can use this pipe symbol, not to be confused with the other pipe that we know, to match this string or this string. Okay. And now it says, yep, it found Taylor in the first string here, and then it found this in the second string here. Okay. So keeping in mind now how we can match multiple variations of a string like this, let's see how many of Taylor's songs mention the word midnight or all lowercase or midnight with a capital M. Okay. So let's remake that variable to say midnight or midnight. Okay. And then or midnight. Now we have 8 instead of 6. Okay, so there was 2 additional songs once we included midnight with a capital M. Okay. So always good to be careful or considerate of capitalization when working with character strings, especially when trying to match them. Another useful function in the stringr package is the string count function, which can tally up the number of instances of a particular pattern in a string. So for example, in some lyrics from Taylor's song, The Man, we can detect how many times in this part of the lyrics, for example, that she says the word man. So I'm so sick of running as fast as I can. Wonder if I'd get there quicker if I was a man. Skip them coming at me again, because if I was a man, then I'd be the man. Man. Okay, so she says man 5 times in this string here. So using this string count function in tandem with the mutate function, we can, for example, create a new variable called love count that for each song shows the number of times Taylor mentions the word love. Oops. Okay. So let's call this love count. It's our new variable equals string count. Let's say pattern equals love. You can do or love. I think trying this out, she only mentions love all lowercase, so this will return the same whether you include the or not. All right, and then we're talking about her song lyrics, which was in the full underscore lyrics variable. So we can run this, get a love count here. Okay, so for example, Ready for It mentions love twice. Let's see. Gold Rush, her song, mentions love 4 times, I guess. All right. So which song mentions love the most times, and how many times is it mentioned? Okay. So a few different ways we could figure this out. One is to use the slice max function. So make sure you run this code to make the new variable love count. And after you do that, we can do slice max love count, saying return the rows with the largest love counts. We want the top, just one row, very top, most times love was mentioned in a song. Okay, and then this will return all the variables by default. We are just interested in so we can use the select function. We're just interested in the song title, which is given by track name, and the number of times that love was mentioned, so love count, that variable. Okay. So her song, This Love, mentions the word love 52 times. All right, that's a lot. Okay. So that's the string count function, useful for tallying up instances of a particular substring. Now we'll look at how we can modify different parts of character strings. So for one of the most common operations that you need to do with character substrings, with character strings, is to concatenate them or combine them together. So for example, if we have this string ..ru, we can paste that together with, or concatenate it together with ready for it to get one single character string value. Okay. This was doing it with 2 individual strings. This is what we call a vectorized function, because you can have a vector of characters on each side and it'll paste the individual components together. So for example, the letters function or letters object in R gives the alphabet, all lowercase for lowercase letters, and then like this, we can get all the uppercase letters. We can paste or concatenate them together component-wise using the string combine or string concatenate function. Just like this. So that's something you may need to do. There's not really instances in this data set just yet that we'll use string combine for, but looking at another very useful function from the stringr package is this string sub function, which is useful for extracting or modifying a substring, which is a subset of the characters, in particular, a subset of contiguous or consecutive characters within a string. So for example, if we have the string Eras Tour, we can extract the first through third characters using this code, which just gives us era. What's nice about this substring function is we can also start from the back end of the string, the end of it, saying start from the very end to the 4th character from the end. And so you always have to do the smaller number is the starting point and the larger number is the end point. So this one's smaller because it's negative. It's more negative. So this allows us to essentially get the last 4 characters of the string, regardless of the length of the string here. So sometimes it's helpful to start from the end and work your way back through the string like this. Okay. So that's the substring function. Again, another common operation is that maybe you want to replace particular strings with something else. Okay. We can use the string replace all function to do this, to replace a particular substring that we don't want in there for some reason with a replacement of our choice. So for example, looking at Taylor's lyrics again from the man, we could replace the word man with 3 exclamation points throughout. Okay. This wasn't very necessary here, but potentially, maybe if you wanted to display all of Taylor's lyrics, but say remove swear words, you could replace swear words with a slight variation of it. We'll look at how we can use this string sub function, not string subset, string sub. How we can use the string sub function, the substring function, to view the YouTube duration variable. Because this one was a little bit problematic. So let's look at this variable again. Okay, so if we look at our output here, here's the YouTube duration, the length of time that the YouTube video is, its duration. When we get data like this, again, the information is in there. So the first video is 3 minutes long and 31 seconds. The second video is 3 minutes long and 51 seconds. Okay. The information's in there, but it's a little bit hard to get that out, to extract that information. Here's where we can use the substring function, string sub, to extract parts of this string out to build a more clean or tidy column for the duration of each YouTube video. So we're going to use a few different stringr functions here at once. So first, we're going to be making a new variable in the data set. So we're going to say Swift songs, reassign it with this modified version of Swift songs. We're going to use mutate. Okay. All right. So we're going to create a new variable called YouTube time, which would be like a tidy version of the YouTube duration. But we'll first replace the capital M, which is always right in the middle here, with a colon. Okay, because this is really like 4 minutes and 56 seconds, for example. That's more traditionally written with 4:56. Okay, so we're going to start our process of cleaning this up by replacing M with a colon. So YouTube time equals YouTube duration, but we replace so the pattern that we want to replace is M, and replacement, what we want to replace it with, is the colon. So if we run that, you can see here this worked. We now, instead of PT3M31, we have PT3:31. Okay, so we're getting a little closer. It looks a little bit more like a time. We don't want these PTs that are in front of every single time component here. That doesn't tell us anything, because every single time we look at it starts with PT, and also every single time ends with S, it looks like, or most every single one. Yeah, most every single one, not all of them do. But the S is not meaningful here, at least not at this point. So we're going to get rid of the PT, and we're going to get rid of the S in the string. Next. So we could use the string replace all function and say, find P and then replace it with an empty string to get rid of it. This is such a common thing that people want to do, to remove substrings and just replace it with nothing, that Hadley created a whole function to do this called string remove all. So for example, we can remove all A's from a particular string here, like this, or remove all A's or R's in the string. So this and this are removed. Okay. So we'll use this string remove all function to now remove those PT and S letters. So how we're going to do that is we will take this code and then add on. So we say YouTube time. We already replaced now the M with a colon. Now we can say string remove all. And now we just say the pattern, because the replacement is always nothing for string remove. So we want to remove E, T, or S. And you can do like P or T or S. That would work as well. Let's just look at this. Okay, now we can see it's looking much more, much closer to a time format that's easier to work with. It's almost there. So we replaced the M with a colon. We got rid of the PT and the S at the end. So now many of the times look okay. There's some problematic ones, right? So this one was supposed to be 3 minutes 31, 3:31, that looks good. 3:56, yep. Okay, but then we get down here, 4 minutes and 8 seconds. So there's no, should be a 0 before the 8 here. 4:08. The way it's coded up, we didn't add this, unfortunately. Okay, and that seems like a problem for some of the columns. Okay, so now we've got, we're a lot closer, but we're still not quite there. So how can we handle this? Well, let's see. So we can fix this using the case when function together with string replace all and string length. So the string length function, the string length function returns the number of characters in a particular string. So let's say in the word Swift, there are 5 letters, 5 characters. So string length around that returns 5. We're going to use this string length function because conditionally, depending on the length or the number of characters in each of these times, that affects how we want to handle the string. Okay, so if, for example, there are 4 characters, for example, in this one, 3:31, we want to leave this as it is this time. Okay. This problem is a little bit, we can make some a little bit of assumptions here because this data set's small and we can look at all the possible problems here already. So this might not be for a much bigger data set. We maybe could not assume this, but for here, we can assume that if there's 4 characters in here, the time is made correctly. It would be more complicated if there were an hours component to the YouTube video, which some videos are over an hour, in which case there would be another component up here. that would be problematic. Or if a video was less than 1 minute, I think this would be formatted differently. But here, because all of Taylor's videos are at least 1 minute and less than an hour, this is an assumption we can make. Okay, so that if there's 4 characters, it's okay. If there are, let's see, if there are 2 characters, so for example, here, this video is exactly 3 minutes long. There are 2 characters, we want to add 2 zeros to have it be 3:00. There's one other song I think that had exactly right on the minute in terms of its duration. Yeah. So this is another one that's exactly 3 minutes. So we want it, when it has 2 characters in here, we want to add a 0 and a 0. And then similarly, when there's 3 characters, we want to add a 0 in between the colon and the last number. Okay. So this is showcasing how, yeah, some of these working with strings can be a bit of a pain like this because the solution is not super simple, but it's easier than it would be without Hadley's functions, that he made. So thankful for those. So let's see. So we're gonna, yeah, add a new column to the Swift songs data set. So we're gonna use mutate. All right. We're gonna modify the existing YouTube time variable that we made. And we're gonna add zeros to the time when needed. So they're not all trailing zeros. So we're just going to add zeros when needed. Okay. Because sometimes one of the zeros was inside the middle of the string, so like it's not technically trailing. Okay, so the case when function will be useful here. Okay, so when, as we were saying, let's start with the worst case. When the number of characters in YouTube time is 2, we want to add, or we want to set it equal to itself concatenated with 2 zeros. All right. When the number of characters is 3, let's see what we want to do. When there's 3, we can't just simply add 2 zeros. We want to insert a 0 in the middle of here. So a few different ways we could do this. One is to replace the colon with a colon and a 0 appended to it. So let's do that. String replace all. And then when the string length is equal to 4, or we'll just say all other cases, just keep it as it is. And it's important that we only run this code once, so that we don't keep modifying the YouTube time variable over and over again. Okay. If you end up accidentally having run it a couple times, you might just need to clear out your environment and then sort of start and rerun the chunks starting from the top to the bottom again. Okay, let's knit this. All right. We won't see any output just yet, but if we had run this code, we can see in here. Let's see if we fix that last column now. All right, so for example, yeah, when there was 3 minutes exactly, now it says 3:00. That's great. What about when there was a 0 in the middle? Okay, so here 4:03, 4 minutes 3 seconds. Looks like that was made well. Okay, correctly. Great. So now we have this YouTube time column, which gives the duration of the YouTube video. Bit of a hassle to make it. That's character strings for you. Now we could, for example, use one of Hadley's lubridate functions to convert this to a date time variable. But since this is a stringr activity, not lubridate, we won't go that far here. But now it's in a nice format that could be handled with the lubridate functions from Hadley's package. Okay. All right, so the next thing we'll look at is capitalization and spacing issues. All right. So these functions are more simplistic than the previous functions we've looked at. That doesn't mean they're any less useful. In fact, I use these all the time, and I think a lot of people find them very helpful. The string to lower function converts characters to all lowercase. String to upper converts all characters in a given string to all uppercase. String to title converts the first character of each word to be uppercase or a capital letter. Okay, and then we can see how that looks here. Get rid of these extra. You got some of Taylor's lyrics. The first one made them all lowercase. Next one made it all uppercase. If you want to yell. And then title case here, it made the words all capitalized. Notice that maybe for some title conventions, you maybe wouldn't capitalize the words to or a. stringr is not that smart, so it'll just capitalize every single word. There's also a string to sentence function that can be useful, that capitalizes only the very first word in the string, although that's how this string already was. So those are kind of some little helper functions that can come in handy. Sometimes you're given a string, for example, this has happened to me a number of times, that's all uppercase. And for some reason, maybe you want to convert it to just regular case or lowercase without having to retype every character yourself. This can be super helpful. Okay. Some other helpful helper functions, we would call them. There's a string trim function, which trims or removes off trailing or leading spaces on a string. So if you have extra spaces at the start of the string, which sometimes data comes that way, or at the end, this can chop those off. And the string squish function is very similar, but it will also condense down a string that has many extra spaces that are contiguous inside the string. So Here, for example, looking at some of Taylor's lyrics from the Bejeweled song. There's some trailing, or there's some leading and trailing space here. So using string trim, it cleans that up, gets rid of those. But when there's extra space in the middle, string trim does not handle that. It doesn't get rid of that, but string squish will condense or squish the string together. So it removes both leading, trailing space, and it condenses multiple consecutive space values or white space values inside a string into just a single space everywhere. Again, very helpful, especially for like open text data where maybe people are just typing a response to something. They accidentally hit the space bar a bunch or too many times. You can clean it up in a programmatic way here rather than having to go in there and manually do it yourself. So that's the last thing we'll look at for this activity. There's some bonus parts if you want to try that as well yourself, but those are optional. Just a little bit of extra challenging questions. So that's it for stringr.